Hi everyone, my name is Joshua from Tag. Let me welcome us back again to my channel. This is my first video for the year, and I want to say thank you for everyone that joined in the course of the previous years. And so what we'll be doing today will just be a continuation of what we did in the last year. So basically we'll be learning how to random numbers in R using some dedicated functions. So I'm going to set a seed. This is just for the purpose of reproducibility in case you want to have the same result with what we're doing right now. So I'm using the seed 101. So I'm going to create an object called x, and I'm going to use the random number generation function in R. I'm going to randomly generate 10 numbers with the mean 5 and standard deviation of 3. So we have the numbers displayed on the global environment. So for you to see the numbers, remember this function is very useful. So you could print x and you could see it has 10 float values with some values of numbers after the decimal. So now the first thing we're going to learn is how do we round up these numbers to a certain digit, either 0 digit, 1 digit, etc. So we're going to use this function called round. So this function comes from the base package, and the argument it needs is just the vector and the specific digit you want it to round it up to or round down to. So I'm going to say round, and then we're supplying it with the vector x, and I just want to start with the 0 digits, so for us to have an understanding of what this function does. So when you check what we have on the console, we have 4, 7, 3, 6, 6, 9, 7, 5, 8, and 4. So what this has done is just to round it up to the first, let's say, first significant figure. So, but in this case, I'm going to use the word digit, the first digit. So the digit starts the count from a 0, 0, 1, 2, 3, 4, just like it is when doing some kind of numbering with Python. So if you are to run it up again to the next one digit, so which is going to be like one decimal place, so you're going to use this round x and then you put 1, so you have these values 4.0, because the number we have after, if you check on the global environment, if you're rounding up a number, so one of the things you take into consideration is the number after that particular digit. So to one decimal place, the number after it is 2, so we round it down. So that's why we have it as 4.0. In the case of what we have in this place, 6.66, so the number after it is above 5, from 5 upward, so we can round this up, so it's gonna change to 6.7, and that's the way we have the answer printed out on the console. So you could as well do it to the level of 2 digits, and so it's still going to follow the same procedure. So when you check on the global environment, you would realize that when you print x, if you go back to line 3 and you run this line of code, you still have these values in these long decimal places. So if you want it to be rounded up to just one decimal place, so you're going to do the concept of reassigning. So I'm going to say x is this, and you're going to run s back. And so if you check the global environment, you could see that we now have a value. If you go back again and print x, you have this value as 4.0, 6.7, 3.0, now rounded to one decimal place. So just like what we've done right now. So there is again another concept in R called the ceiling and floor, the ceiling function and the floor function. So let's see what this particular function does. So if I say ceil up the vector x, so I'm going to say ceil and then I put x. So if I run this entire thing, so what it's going to do is just from the word ceiling, you just want to seal up everything. So it means whatever number it is, just run it up to the next value on the number line. So if I run the ceiling for x, and so you're going to have 4, 7, 3, 6, 6, 6, 9, 7, 5, 8, 8, and 5. So you just ran it up. You just rounded it up. So 4 remains at 4, because the 0 it's insignificant. So but if you see 6.7 goes to like 7, 3 goes to 7, 5.6 go to 6, so it does the rounding up. And you see 4.3, it goes to 5. Even if it is 4.2, 4.1, it all gets rounded up to 5. So this, let's see again the floor function. So we say floor of x, and so we run this. What it does, it also brings it down. So 4.0 still remains as 4, 6.7, irrespective of the fact that 7 is a bigger value that could turn 6 to 7, so we still leave it at 6. It floors, it just basically rounded down, and that is basically the same thing with what the trunc function is doing. So if you say trunc of x, it does give you the same answer. So before I go to talk about like the concept of outlier, just to round up everything we have and move to a new phase in line with what we have in my book, Basic Statistics for Undergraduate Studies Using R. So we're just going to talk about the parallel maxima and minima function in R and what it does. So we already have like S created, but what I'm going to do now is to turn completely S to the values in S to like a whole number. So what I'm going to do is to go back to what we have in this place, and instead of using one digit, I can easily copy what we have in line 6 and bring it down here. So I have this pasted, so now I'm turning it to just whole number, and so we have 47366875884. And next is for us to again generate some random numbers using the random number generation function in R. We just need 10 numbers as well, and so we still want it to have the mean of 5 and standard deviation of 3. So when you run this, you also have the same thing. So what I'm going to do again is to reassign and say this, just use the rand again, or you could choose to use either cell or like floor. So just round it as long as it brings it down to whole number. So we're doing the rand, and now we're rounding y, and we're rounding it again to a whole number. So we could see on the global environment we have values ranging from 1 to 10 with just one non-positive value, which is the -1. So now let's have to talk about the parallel maximum. So the function in R is pmax, and it also comes from the base package. So I'm going to say pmax of x and y. So what it's going to do is going to do like a kind of column-wise comparison and brings out the bigger value. So if I have like pmax, so now it's going to do the comparison between the two vectors, and in the first case 4 and 7, the bigger value is the maximum is 7. In the next, we still have the maximum coming from the first vector, and this we have the maximum coming from the second vector. The maximum 6 coming from the first vector, 6 again from the first vector. In this case, 6 is bigger than 4, 8 is bigger than 4, 7 bigger than 2, so we have 7. Here is 5, and here we have 8, and here we have 4. So this is the concept of parallel maxima. So you could as well have the parallel minimum, and it's still going to work again doing the column-wise comparison. So if you run this whole thing, we have an understanding why we have 4. It's just like the opposite of what we've done before. So this minimum is 4 in the first row or column, as the case may be, in the first column, and then the minimum again in the second column is 3, because 7 is for sure greater than 3. So this is how the concept of the parallel maximum and the parallel minimum does work. So we're just going to do like an example. For instance, that we have a situation where we have like some missing value, and we are trying to like see the parallel maximum between two vectors. So what do we do? So now I'm going to create again, I'm just going to reassign or do some kind of manipulations with what we have for the value of x. So I'm going to turn what we have in the first position in x, I'm going to turn this to a missing value called like an NA, and then I run this. So we have an NA now taking the position 1. So I'm going to run again what we have in the first line, like parallel maxima, and I'm going to say x and y. So if I run this, for sure in the position of 1, when doing the first comparison between the first column 7 and NA, we have NA. So in this case, just like I've said in the previous videos, when you're doing anything that has to do with some kind of arithmetic kind of operations, so for you, and it has an NA, so you just have to introduce this function, this argument called NA.rm, and you set this to be true. So in this case, if I run this, then we're going to have like 7. So it's going to completely omit the NA. So you're just going to compare 7 with just 0. And in this case, the minimum is still 7. So you can try to like do some kind of comparison again and say 7 p minimum, and then say x comma y, and here say na.rm, and then say equals true. Let's see what happens. So you could see it still gives us 7 and prints out the minimum for the rest values. So, and in the case where we have, okay, let's just treat this in case where we have like comparing between two incomplete vectors, like let's say vectors of unequal lengths. In this case, we have vectors that are of length 10. In the case where we have like x to have like vectors that have like 8 values in it, and y as 10. What else happen when we're using this concept of parallel maxima? So I'm going to change like x, and I'm going to say like, okay, x right now I want to change, like I want to exclude what we have in the first, okay, in from the first to 2. So I'm going to say x, and I'm going to use the square bracket, remember, and I'm going to do this like concatenate them together, and I say 1 and 2. So then if I run this, so I reduce successfully x to have just 8 values, and I'm going to say again pmax, and I'm going to like do this kind of parallel maximum comparison between the two vector that has like length of 8 and length of 10. So if I run this, then I have like a warning message printed. An argument will be fractionally recycled. So there is this concept of recycling taking place. So what does this recycling does? So now everything still works fine to the level of comparison against the first 8 values, and now at the level of 3 and minus 1, x have no values to be compared with the values of y. So it's going to recycle, go again and start from the beginning. So the beginning is going to be 3 compared with the 3 we have in y, and that's why we have 3. And the next is 6 compared with minus 1, that's why we have like 6. So next thing that I'm going to do is to talk briefly about the concept of an outlier. And basically we all know what an outlier is. It's that kind of observation that doesn't fit well with the data. So I'm going to create like a simple data, and I'm going to call it like data, and I'm going to use the concept of vector. I'm going to say 0.7. I'm going to say is minus 0.6 minus 0.6, and I'm going to say I'm doing this exactly the way it is on my textbook, so we don't have like much mistakes. So I have like minus 0.1 and minus 1.0 minus 1. No need for me to put 0. 0.4 is 0.3 minus 1.7, 1.1, and 4.0. So then I run this entire thing. So we have like 10 observations. So let's have like a plot. This is just something very simple. So we're not yet talking about like visualizations in R for now, but we just want to visualize the outlier in this case. Visually looking at it, if you look at these values, we could see that most of it range between 0 and 1. The only outlier we have in this data, like something strange, different from the others, is the positive 4. So how do we visualize it? So I'm going to say like data, and I'm going to replicate zeros, like 0, and I'm going to do this for like 10 times, and I'm going to say like I just want the as-is to be printed. So I said as-is, and I said as-is is true, and I said while I'm not giving any label, so I just leave it empty, and then I go and I say like the sex, I put 2, and then I have again sex dot as-is, as how thick I want the as-is to look like, and I said this is going to be 1.5. And I could break down the code and say axis again, and I just want axis to be 1.5, 1.5, and the next thing I'm going to do is to say sex.label, and I also want it to be 1.5. So equals to 1.5. Yes, again I'm going to go down without running it, so I'm going to add like an outline, and I'm going to say this outline I want it to go horizontally from the point of 0, and I'm going to give it a kind of color, and here I'm going to call the color like gray. I'm doing all these things using the base R without having to do anything with some advanced visualization packages in R, which we'll still talk about. So I said the line thickness, and I said this is going to be 2 for the outline. Again, I'm going to add an arrow to like show us, point exactly to where we have the outlier, exactly the way it is in my textbook. 3 is 0.3 for the position of the arrow we want to bring in, 3.9, 3.9, comma, and then we have like 0.1, and the line width I just want it to be 2, and so I still leave that as it is. And finally I'm going to put like the text, where do I want the word outlier to appear. So I'm going to explain all these things. 3 is 0.45, and then I'm going to say labels. I'm going to say labels, and I'm going to call this like going to be quoted. I'm going to call it this is an outlier, right? Just add this question mark, and finally I'm going to add like how do I want it to be thick, how thick do I want it to look like. So I put 2. So now let's run the plot. I'm going to increase the plot pane in this place, so like we could view it like in a very bigger version. So I'm going to run what we have in line 29 down to 30. So when I run this, we have this. So visually looking at this, we could see that this value here is like an outlier, something different from the entire data set, something that does not fit well with the data. Just like an example, when you're in a class and you have like some undergraduate students with a professor, and so you're like trying to like have an idea of the income of everyone in the room, including the professor. So for sure the salary of the professor will be an outlier, something far different from what an undergraduate will be collecting. I mean, here I'm talking in a sense that we have an idea of what an undergraduate salary looks like, let's say $2,000, let's say, for instance. So we're going to run this outline, and it goes directly horizontal from the point 0, and you could see the line, the color we added here is just gray, and R Studio makes it very easy. When you write any kind of color, like here we say gray, and then it gives us the exact color of gray, especially for those of us that may not really understand, may not know much about color like me. So here we have like color blue, and if I run this again, the outline change to blue. I think it would be nice if I make it blue. And so what this line thickness does is how thick do you want it to be. So I'm increasing it, like let's say I want to make it 10, so you could see it makes it a bit thicker. So now we want to like produce an arrow, and this arrow has like 4 dimensions that we want to bring it in on the line. WV again, which is just like the thickness of this arrow, is what this particular code in line 32 is all about. And so the final thing is to bring in the text, and the text takes this position 3, and this is 3 that we have, and is 0.45. So if you check what we have in this place, which is the text is going to be around here, exactly x coordinates here will be 3, and this will be 0.45. So if I run this, we're going to have this particular value that the arrow points to is an outlier. So I want to believe we will enjoy this teaching, and I look forward to seeing you in the next video. Thank you very much for your time, and God bless you.